My area of work has been always trying to give voice to people who have lost their voice as a result of a range of conditions. That has been my passion. Previous technology, electrolarynx, which is a handheld device that generates a robotic voice, or they use a plastic valve that they surgically place inside an open wound in the throat. Electrolarynx is completely independent of human way of voice generation. You ask a patient to control the onset and offset of their voice, but we actually don't know how to do that. I don't decide how am I controlling my voice on and off as I speak, right? It's automatic. So electrolarynx has been a failure for 30 years. At least more than 500,000 people who have basically no voice. They have, unfortunately, the second highest suicide rate among cancer survivors. Our device is actually the future of voice prosthesis.
My biggest influence in life has been my mother. She's strong and kind and intelligent, and I'm so glad that she's here with us. She actually had tuberculosis when she was young, and she spent 2 years in hospital in isolation in her early 20s. So that was 60 years ago. We've come a long way in our science and our medicine. However, we've still got a long way to go. And I think just growing up knowing that such a tiny bacteria had such a big impact on her life, it really did sort of direct me and lead me towards science. Started my own group at the Institute for Glycomics, happily researching, trying to make some breakthroughs in preventing some special infectious diseases. We have microbiologists, chemists, computational biochemists, lots of people working together. My research really focuses on a few different areas. It's the interface between microbiology, molecular biology, drug discovery, vaccine development, and it's a great field because we have a lot of experts in different areas who all come together to try and tackle some of the big problems that we have and solve some of these infectious diseases that are causing really big problems around the world.
We do what's called translational science, and that means that we don't just work at the laboratory bench doing basic science. We actually take our discoveries right the way through to testing in humans. So we'll develop a new drug or vaccine discovery in the laboratory, and then we'll develop that discovery right the way through to a product that we can test in people. Once we've tested that product in people, we then typically partner with industry to take that product through to market. Lumina now offers a really sophisticated environment. We have expertise around the precinct that actually can assist with commercialisation and can provide advice on how to develop a technology, how to develop a product from early inception, concept phase, right the way through to a product that can be tested in people. The infrastructure that's being provided as part of Lumina will facilitate new companies coming to the Gold Coast and growing within the precinct, but also stimulating and encouraging locally homegrown talent, locally homegrown businesses and startup companies that will thrive in this precinct.